So this says you decide to start your own business of washing dogs. First, you purchase $50 in supplies. When you buy a 32-ounce bottle of shampoo for $4.79, the label says that it will wash a dog 32 times. Find the per dog cost for the shampoo. Describe how you found the amount. So to find the per dog or per wash cost, what we're going to do is we're going to take the bottle cost, which is 4.79, $4.79, and divided by however many washes we're going to get out of it. And we're going to go ahead and use a calculator to figure that out. So 4.79 divided by 32. 4.79 divided by 32. So basically cost, we'll round off to 15 cents is the cost per wash or the cost per dog. So we'll come back over here and say that. So it costs 15, and we'll leave it in dollars. 15 cents per wash. Since they say per dog, we'll just go per one dog. Or you could write it as per wash. So the next question says, determine the cost equation for washing dogs. Don't forget that you spent $50 on supplies. This is going to be a linear equation because there's one fixed cost per dog or per wash. Um, that's a constant. And then there's the flat cost of $50. So that ends up being, we'll just go ahead and use our typical variables, which are y equal mx plus b, and the rate is this. So this is the slope, and then the y-intercept is this piece. So our equation then, that's our cost equation, is 0.15x plus 50. Now, sometimes, and we'll see if it's worth doing this, they want it as a cost equation. So cost of x is 0.15x plus 50. If it's valuable to use the c instead of the y, we can switch at some point. Now it says your mom offers to pay $3 for your dog to be washed. Explain below why you think your mom's price is reasonable, too little, or too much. Remember, your goal is to make a profit. So number 3 states, your mom offers to pay $3 for your dog to be washed. Explain below why you think your mom's price is reasonable, too little, or too much. So ultimately, this is going to be an opinion question, but we could uh, approach it analytically and just so that we have some clear equations. We're going to call this y1 and we'll label this somewhere. This is the cost equation. What is being alluded to here is that you have another equation that we can refer to as the revenue equation. In other words, how much money you're bringing in. And what mom is suggesting is that every dog should bring in $3. And so the question uh, is this a good uh, price to charge, too little or too much? And so what I would do on this one to analytically think about how we answer that question is see what happens when you say, um, let's say that you wash, um, something like 15 dogs at that price. And if you wash 15 dogs at that price, you're going to make $45. If you compare it to the profit you would make, let me use a calculator. So we're going to plug in the 15 into the other equation. So excuse the annotation there, but we're gonna plug in, we're gonna say 0.15 times 15 plus 50. That's gonna tell us that we are actually spending $52.25. So Y1 will be $52 and I think it was 51 cents. Oh, 25 cents. 52.25. So if you wash 15 dogs, which is quite a lot of dogs, I would say, um, you're actually at a loss because you're only bringing in $45 and it's costing you more than $52. So you're actually down $7 and 25 cents, I believe. So it's not a very good deal if you're going to wash 15 dogs. So before you answer this question, plug in, something like 50 dogs or 100 dogs, and then see if your profit is worth um, is worth all the dogs that you're washing. And then you can answer that question again using opinion, but opinion based on a mathematical analysis. Okay, so you may have had a positive opinion or a negative opinion about mom's suggested price, but we're just gonna go with the $3 to think further about how to analyze the situation. So this says graph the following equations. Y1 equals 50 plus 0.15x. Doesn't matter that they put the slope at the end, uh, and the flat cost at the beginning. And Y2 is 3x. So that's basically the cost equation and the revenue equation. And so they want us to graph that. So we're going to go ahead and go to our calculator. And we're going to go to our equation editor. And inside equation editor, we're gonna type in We'll do it in the regular order, which is 0.15x plus 50. And then the other equation is 3x. So those are our two equations, and they're asking us to graph them. So let's see what happens. Let's see if we could see them on the graph. You could see one of them. And if I hit trace, you could see that that equation is actually the 3x one. So we're going to have to do a little modification on the window because remember the y-intercept on the first equation is a 50. So why don't we change the y max? Um, let's go. We could take the 50 and just double it. That might be a little too high. Let's try 75 and see what that produces. And also, we might be interested in seeing what happens uh, when you wash, say, 30 dogs. So, or as many as 30 dogs. So we can adjust the window until we're happy with the picture. But let's see with those modifications what we get. So I like that picture because you can actually see where the two lines cross, which is going to be important here in a minute. So we've gone ahead and graphed it. And the question number 4 says find the intersection point of the two lines. And then it says record your answer. So that's something that we can get the calculator to do for us. And basically what we'll do is we'll go back to the graph, which we have a good window, and we're gonna go second calc, and the calculator itself can help us find the intersection, obviously number 5. And the only thing you need to do is tell it which equations to utilize by pressing enter. So right now the cursor is blinking on the blue equation, which is the 0.15x plus 50. I'm gonna hit enter. Then it goes to another equation. If there were multiple equations, you'd have to make sure it was on the ones you were interested in, but there's only two here, right? So it's just a matter of pressing enter. And then um, it has this guess feature that I don't think anybody really uses. So we're just gonna ignore it. The way you ignore it is just press enter. And it identifies the point of intersection, which is basically, it represents two things. The mathematical thing it represents is the solution of the system of equations, because this is the system of equations. There's two equations, right? And it also represents in terms of the story problem, in terms of the word problem, it's the break-even point. So 17.54. Let me write that down. And the output is 52.63. Let me double check that. Yeah. And so that is the point of intersection. So now the next problem number 5 says interpret the point of intersection in terms of your business of washing dogs by explaining the meaning of the ordered pair. So what the point of intersection is, it's the point of intersection represents the number of dog washes that will yield the same amount for the cost and for the revenue. So it's the only point that belongs to both equations. Um, Probably the more or another way to understand it is uh, this point is the break even point. In other words, your profit will be zero because it'll cost you $52.63 to wash 17.54 dogs. And you'll also bring in $52.63 if you wash 17.54 dogs. Of course, you're probably thinking to yourself, that's not a realistic value because you either wash 17 dogs or you wash 18 dogs. You can't wash a fraction of a dog. Um, but algebraically, that's your break-even point. Now, for the next question, it's saying solve the problem algebraically by setting the equations equal to each other. So since we have some space on top, I'm going to go ahead and do that on top. The equations were 50 plus 0.15x, and we want to set that equal to 3x. Again, what that's implying is that the cost will equal the revenue. In other words, your profit will be zero. Okay? But I'm going to remove this so that it'll be, because I need the space to solve. So what I'm going to do is I'm going to subtract 0.15x from both sides. That leaves me with 50 is equal to 2.85x. And if I divide both sides by 2.85, now you can check this with your calculator, but what you're going to end up with is 17.54, which is the same answer we just got with a calculator. And then you take that value and you can choose to plug it in here or here. Now, obviously in this case, it's easier to plug it into Y2, so I'm just going to go with that. But assuming you did all this correct, you're going to get the same answer regardless of which equation you plug it into. So it's 3 times 17.54. And you can verify this with your calculator, but you'll end up with 52.63. I guess we can verify that one. 3 times 1754. 3 times 17.54. Let me try that again. 3 times 17.54. And we get 52.62. And I think we did some rounding off at some point. But it's close enough. 52.62. So we'll just do that one. We'll just revise it. But it's close enough. We did some revising. I'm sorry, some rounding off. And that's why we ended up with a slightly different answer. But it's definitely close enough to know that we did the right thing using both methods. So for the last question on this recording, we're gonna answer number 7, which says, will you make a profit before you have to buy more shampoo? Remember that you can wash 32 dogs with 1 bottle of shampoo. So let's plug in 32 into both equations. And see what we get. And then we'll decide whether that represents a profit or not. Now, we could do this by having the calculator do the straight computation, but we're gonna do it in a slightly different way. And so just remember the number 32, and we're gonna switch over to the calculator now. And what I'm gonna do is I'm going to go to where it says table set. So I'm going to go to second table set, and I'm going to switch the independent variable to ask. And from there, I'm going to go to the table by hitting second table. And what I'm going to do is plug in the 32, and it should automatically fill in the answers for the 2 equations for me. So you could see at 32 dogs, it's costing $54.80, and the revenue is $96. So in fact, 96 minus 54.80, 96 minus 54.80, 96 minus 54.80 is $41.20. So you do make a profit before you need to buy another bottle of $41 and some cents. And you could test out other values, say 10 dog washes. It's costing you $51.50, but your revenue is only 30. So that's a loss. You could say, well, what happens when I wash 100 dogs? Well, it's costing you $65 to wash 100 dogs, and you're making $300. So at that point, you're making a $235 profit. On the other hand, 100 dogs is a lot of dogs. And so really they want you to answer a question about 32 dogs, which you can do now. Um, and so for the rest of the problem, you're going to be changing the cost of washing a dog to $4, and then you're going to solve the system, and you're going to think about profit a little bit more. And so that what we've covered so far should set you up to complete this assignment on your own.